And again, thank you, everybody. Welcome to the February technical and dinner. Eventually, one day it'll be dinner meeting.
Kurt, it says you have transcription started, not recording.
Did I do that?
It looks like both.
Yeah, it's
Okay.
recording, but
Okay.
let me stop the transcript. Yeah, that's weird because I just hit the recording and it's it's transcribing transcribing. So oh well, we'll see what happens. Okay, so again, let me make sure I'm still recording. Yep, I am recording. So again, welcome everyone to the February technical dinner meeting. A few things before we begin. Again, just to go over some ground rules. If you're, participants, we try to set it up so when you come in, you're on mute. And so we also want to make sure that and I see everybody, it's just your initials. Like I said, while we like to see your smiling face, you can turn off your cameras, and that helps with the bandwidth. It also it's less distracting. I know I had a meeting one time and I have a ceiling fan. It was in the summertime. That ceiling fan is just fluctuating and it's kind of a little distracting. So again, just a few things. If you haven't used Teams much, these are the buttons that should be at the top of your screen. The one is for a camera, and the other one is for your microphone. Like I said, initially you're muted, but if you want to speak at some point, you should be able to just turn that on and speak. So, all right. Some other ground rules during the presentation. As questions come up, please use the Teams chat feature. And that's one thing we're noticing is that guests sometimes can't get to the chat feature. So the other thing we'll do is I'll have access. What we're saying is if you wanted to add something, is just send me an email during the meeting and I can read them at the end. I can check my mail at the end of the presentation. Yeah, this will open a meeting chat. Type your comments and questions there. We'll review these at the end of the presentation. Like I said, it's a chat feature. We are finding, and I try to set it up so that everyone has access, but I know the last couple of meetings, some people have not. So if we don't have that capability, then let me hit my enter here. If you can't use the Teams chat feature, address the comments to me, kmore@memberleader.asq.org, and I'll open those up at the end of the meeting. Okay, a couple other ground rules. We also have a raise your hand feature if you wanted to have a question or something like that, or join in on the conversation. And you just hit that little, icon and then hit the hand. And then also, when leaving the session, we'd like you to take time to fill out the Voice of the Customer survey. We're going to give you 3 opportunities to do this. First is there will be a web link that I'll post in the team chat during the meeting or at the end of the meeting so that you could have that link. There will also be a URL provided when I send out the participation letter, and I promise I will send it out a lot faster than I did the last one. So try to get that into you tonight, or get that out tonight. And then there's also this QR code, which again, I will show at the end of the meeting. So if you guys got your phone present, you can just, zap the QR code and it'll take you to the Voice of the Customer survey. And so with that, I will turn the first half of the meeting over to the lovely and talented Mr. Grubbs, who will talk to us about measurement system analysis.
Okay, thank you, Kurt. For those of you who don't know me, my name is Gary Grubbs. I'm the section chair, and I've worked for probably the last 42 years at what is now known as Eastman, but has been formerly known as Solution Monsanto, of which the last 25 years have been in quality. We're going to spend a couple minutes tonight sort of going over the basics of MSA. Next slide, please.
Yeah, no worries. Listen, you guys have a lot to offer. There are going to be a lot of people who are going to meet us when this big reveal comes. I need you guys to be well, okay? Robert can
Could somebody put their mic on?
Trying to check to see what we got here. Get somebody on.
get better, you guys. And I'll talk,
Oh.
I gotta do this thing, the video started, so.
Yeah.
Yeah, I was muted. I got it.
Okay. Before we start, one of the things I want to go through is some vocabulary, because I'm going to be using some terms that I'm not sure everybody's going to be aware of. The first one is AIAG, which is the Automobile Industry Action Group, which is effectively owners of the ISO 9000 standard for the automotive industry. Accuracy is simply how close a measurement is to a true value. We'll talk a little bit about analysis of variance, which is nothing more than a statistical tool to determine if averages of variables, in this case, it's going to be the process, the equipment, or the people, are significantly different from one another. Attributes are measurements that are discrete. So that's going to be like high, medium, and low, level 1, 2, 3, 4, 5, good, bad, shiny, dull, things like that. Bias is how well your measurements compare to a reference or a reference sample or part. I'm going to use the word sample because that's the thing that I'm most familiar with. But when I say sample, it's going to also mean the word part. A crossed MSA is where every operator measures all samples and all parts on each machine. And obviously that's one of the better ways of doing it. But we're going to get down in a few minutes as to another type, and we'll sort of explain why that might be more appropriate. I don't know if you ever heard of the term flinching, but flinching is an official error where people make the wrong decision because they're afraid of making the right decision, which is typically sort of using very liberal rounding rules when material is out of spec. Linearity is how accurate are the measurements through the range of your measuring equipment. And I told you we were going to talk about another type of MSA, and that's called a nested. A nested is with any one or more of the following is similar but not the same. That would be the operator, the sample, or the machine. Where would you want to use this? Well, let's say you're comparing operations from two different plants. So you might use similar machines, similarly trained operators, and even similar samples. Obviously, you would have to use this if you're doing destructive testing. Next slide, please. The number of distinct categories. That's really, if you look at the span of your measurement system as it relates to your process, how many distinct categories can you really differentiate within that measurement system? And we're going to see that later when we get into the example, that's a very critical number, and it has to meet some requirements. The p-value is the statistical probability of an event. The example we're going to use is operators and parts. And when the calculated value is greater, is compared to the expected value, which is going to be 0.05 in this example for a 95% confidence, it's greater, so the event is not random, which means that it's significant. Don't know if any of you have ever heard of the plan of control, but it's probably one of the most useful tools I learned early on. And picture a process flow diagram where in between the various steps, there's a line that joins the two steps. Well, if you write everything below the line that's critical to make this operation work, and everything above the line you write, these are the tools that are available to folks. We're going to see an example in a minute. It's a very visual way of sort of showing folks that a particular procedure is not very robust. Precision is how close are multiple measurements to one another. Repeatability is the variation of the measurement system when different operators measure the same part on the same equipment. And by the same token, reproducibility is the variability of the equipment when the same operator tests the same part many times. Stability is really just accuracy over time, and then variables are any measurements that are continuous. So that would be things like length, pressure, temperature, ID, OD, etc. Next slide. Talked about a plan of control. Here's a simple part of a process flow diagram where you go from step 1 to step 2. Now, I'm not going to spend a lot of time going over this, but if you look at the procedure as written right now, there's 4 things in yellow. Those are 4 things that are critical to the success of this part of the procedure. And there's only one thing that's highlighted in green above, which sort of says, okay, there's 4 things that are really important to do here, but we're really only giving the person who's doing this one tool to know whether they've done it well or to help them do it well. So picture a whole series of these together. This is a great tool to go to folks and say, look, this is a bad procedure. You really don't have to understand the procedure, but if you look at it, you can see there's very few things in green and a whole lot of things in yellow. Next slide, please. We're going to start off with the basics. MSA is really sort of the way you separate the variation that comes out of your manufacturing process into variation due to the process and variation due to the testing process. That testing process gets broken down into variation from the equipment and variation from the people doing the testing. MSA is about precision. It's not about accuracy. It's about how well our measurements are sort of aligned with respect to one another, not how well they're aligned to the true value. MSA has got to include samples that are evenly distributed throughout the specification of the tolerance range. Once again, I'm going to use the word specification because that's sort of the way I have been brought up, but they mean the same thing. And you got to have some that are above and below that specification range. If you're really going to do a good MSA, focus more on planning the study than actually conducting it. Because if you plan it well, the conducting part should sort of just come along for the ride. And when you're doing an MSA, you want to focus on the variables or the attributes that are in the study, and then try to randomize all the other things to really sort of make it sort of fade into the background as noise. But a few things an MSA is not. Above all, it's not about feeding test data to a computer to generate a study or a piece of paper. It's not about using the best parts of the best analysts for the study. It's not going to solve measurement system problems. Sort of like SPC, it can point you where to look, but it can't tell you what the problem is. It's definitely not going to solve process capability problems like you're operating off target. And next slide, please. Going to go through the scope here. We're going to talk about the precision of variable measurements. You can do an MSA on attributes, but that's really sort of outside the scope. And if accuracy is needed, I suggest you do a gauge linearity and bias study, which is also outside the scope. But as you can see from the bottom, what you do is you take known reference standards across the width of your measurement range, and you have it measured multiple times, and you see how well that compares. Next slide, please. Excuse me. Preparation is really the key. Everything you've got to do is going to focus on your measurement system first. You got to get that sort of aligned. You want to make sure everybody's trained to the latest version. You want to calibrate and verify all the equipment involved. You got to perform the necessary PM service on the equipment. If standards involved, you either got to verify their status or get new ones. If you have fixtures or jigs, you want to inspect them for wear or position. And ideally, the discrimination of your measurement system should be at least 10 times your specification or tolerance width. It would be really nice if you get the process to operate at or near the center of your specification range. Now, if for some reason you're not doing that, I think you need to make sure that if you're going to make this change, you got to understand how your customer is going to see that. MSA is definitely going to be way more valuable when your CPK is low. and you may need some sort of a reality check if you're trying to do an MSA on a precision process. If you're machining something to thousandths and tens of a thousandths of inches, you might be very limited in your ability to measure that real well. So you might want to take that as a with a grain of salt if that's really what you're trying to do. I think the focus there is, are you really making parts that are acceptable to your customer? Then you got to get the people ready. You know, and you got to select the analysts, and what you want to try to do is not put all your best or your worst analysts in there. It would be ideal to get a range of abilities. Then you got to explain the reason for the study and highlight the benefit to the business and the customer. And whatever you do, don't use words like accuracy and precision and crossed and nested and all that other stuff. Explain it to them in plain, simple English in ways they're going to understand. Explain the need to follow their standard routine for testing process, not the special standard routine process for testing when somebody's watching you. You don't want them sharing results. And then more importantly than anything else, make sure everybody understands this is not a time study. It's not going to be used for discipline, and you need to act accordingly. Next slide, please. Then you got to think about your samples or your parts. I mean, ideally, you'd like to take them when the process is operating normally. And you need to have material that's low out of spec, evenly distributed across the spec range, and above the spec range, and not clustered about the mean. You get too many things clustered about the mean, you're going to start having problems with your number of distinct categories. If necessary, you got to consider ways to prevent or at least acknowledge the fact that your sample could deteriorate during the study due to things like environmental conditions, light exposure, contamination during handling and testing, and above all, making sure that the samples are not accidentally thrown out or mixed with standard product. Yes, it does happen. So you want to make sure you go out of your way to make it hard to have that occur. Then you've got to identify and safeguard the samples so that their integrity lasts throughout the whole study. You don't, under any circumstances, arrange them in any kind of a logical order. There are a whole bunch of random number generators either on the web or you can actually now get them from a phone app. And if you do this through some type of software, that'll do all that stuff for you. My experience has always been you want to designate a specific area for storage and clearly mark that what is in this area is for a special study. And if special conditions are necessary, you might want to dedicate a special storage container or conditioner or something like that, and then monitor the conditions of the storage conditions if that's appropriate. Next slide, please. The standard minimum guideline for a good MSA is 10 samples or parts, 3 analysts, each part measured in duplicate. Now, if you look at the graph below, for 10 parts, you could generate as much as 25% of the samples that are greater than 10% of the tolerance based on those 10 samples selected. Drops to 7 when you get up to 30, and it's almost 0 at 100. So you've got to balance the trade-off. Why is this happening? Well, by taking a smaller sample size, your risk of having your data skewed by one aberrant value goes way up. So you need to understand that as you add more samples, you're going to reduce the likelihood of that impacting your results, but it's also going to take more time. So this is really sort of like the standard application of the central limit theorem is the larger the sample, the greater the likelihood is you're going to get things more clustered around the mean, and they're going to be less impact of some of the outliers. Next slide, please. During the study, you got to try to focus on randomizing what you control, like the order of samples, the times when the parts are measured, shifts if possible, day and night. And software really helps here. Once again, random number generator. If you don't have software for numbering the samples and parts in their order, you use a worksheet to capture the measurement order, the dates, the times, the values, and you want to use a unique worksheet for each replicate so people aren't comparing the values. If you have things that are sensitive to the environment, you may need something like a CTH monitor in the area to monitor the temperature and humidity, because in a lot of areas, these things are at best loosely controlled. If possible, a good best practice would be to have an observer. That makes it much harder to compare results between analysts and results between replicates. And it's also a great way to observe differences between and within analysts. And it's an extra set of eyes for the standard things that are going to happen during the study. Like, I don't know, the air conditioner fails, you have a power surge, some sort of a network issue, you have equipment issues, you have an unexpected service or PM. And then, like I say, how do you maintain your sample and your part integrity? In my industry, if you're using bulk samples, how do you make sure your bulk sample stays homogenized? Do you have special storage requirements? And then, I can't stress this enough, preventing accidental disposal or mixing with standard product. Yes, it does happen. I've seen it happen. And if it does, you've got to be prepared for it. Don't freak out. Next, please. After the study, the simplest thing to do is just get some run charts. Obviously, if you have Excel, this is sort of pretty easy to do. And if you have a software package, it's usually done somewhat automatically. We said that this wasn't about finding fault, and we've got to act that way. We want to share the results in ways that the people that participated in the study will understand. And obviously, there's no names. It's operator 1, operator 2, operator 3. And where possible, if you can, recognize and reward the participants. One of the very first ones I didn't do a very good job of managing the results. I got all high and mighty. Oh, well, we've got a repeatability issue. And everybody looked at me and said, well, what's a repeatability issue? I said, well, that's the variation in the testing process that's due to the operators. Oh, well, then it's all you have to do is train them better. Well, you need to understand that training isn't the only possible outcome here. In my case, it was a poorly written procedure. We had a whole bunch of things in our procedure where we asked folks to do things, and we went back to our plan of control. There were a whole bunch of things that were critical for each step, and there were virtually no tools available. And it took about 2 or 3 months for me to sort of get this on board with people to say, look, this isn't a training problem, this is a procedure problem. It could be an issue with a fixture or a jig. Could be something to do with the environment, could be part of a learning curve. It definitely could be due to flinching. And like I say, this is where that plan of control can help you sort of visualize this and share your results with folks that don't know as much about the testing process as you do. But like I say, if you do it in a very visual way, it's easy for them to see that, oh yeah, I guess this isn't a very good procedure, because we're asking people to do a whole bunch of things and we're not providing them with a whole lot of tools to know whether they've done it well. Next slide, please. After the study, you want to check for the number of distinct categories. AIG recommends that at least 5 or more indicates an acceptable MSA. Then you want to look at your total gauge R&R. If it's less than 10% of your due to the measurement system, it's adequate. If the gauge R&R is between 10 and 30%, the measurement system may be adequate, but it may require customer approval if you're going to use it for release. And if it's over 30%, it's unacceptable. Think about what this means. That means you can measure low, medium, and high. That's all you can do. And that's why they're saying that's unacceptable. Analyze the method with the way that you understand best. You've got 2 standard methods, range and ANOVA. They're going to give you approximately the same results. The range and average method is going to be a lot easier if you're going to do it in a spreadsheet. The following is always going to be true. Total gauge R&R plus process variation equals 100%. Repeatability and reproducibility are going to equal gauge R&R. Next slide, please. We're now going to look at the output from Minitab on a cross-designed ANOVA analysis, 10 samples, 3 operators, 2 replicates. First thing you're going to see is this two-way table, ANOVA table with interaction. The thing you want to focus on is the thing that's highlighted. The operator, the p-value for operator by part is 0.974, and that's way greater than 0.05. So that means that the measurement system is impacted by the interaction of the operators and the parts, and that is significant. If I move down to my gauge R&R, second thing I want to look at is the part-to-part variation is 92.24%, which means that most of the variation is coming from your process, which is good. And if you break down your gauge R&R, you've got a 7.76%, which when you add that to 92.24, oh, by the way, equals 100. And then you can break down your gauge R&R into repeatability and reproducibility. So your operator impact is a little less than half, and your machine impact is a little more than half. Both very respectable numbers. Next slide, please. But we only have 4 distinct categories. So what does that mean? That means you can distinguish below average to out of spec, below average, above average to out of spec high. This could mean that the measurement system might not have enough resolution, or the samples are too closely clustered to the mean, or you only use samples within spec. You didn't get far enough away from the mean. Those are the areas I would be looking at. Next slide, please. It's also going to report several graphs, and let's go through them quickly. The first one is just really a bar graph showing the impact of gauge R&R first, repeatability, reproducibility, and then the impact of the parts. If you look at measurement by parts, you can see that there's some wiggle by the operators, but by and large, they're getting essentially the same value. If you look at the range chart by operator, you can see that there's only 1 point that's out of control. So I believe that means that most operators are measuring somewhat consistently. The one I like is number 4, which is otherwise known as a box and whisker plot. From this, it's very graphic. You can see that operator B probably has the widest distribution. Operator C probably has the lowest variation. And operator C also generates the lowest average value, and operator A generates the highest average value. The next one I think is kind of useless. It's called the X-bar chart by operator. And basically, since everything's out of control, it basically says all the variation is due to the parts. I also like number 6, which is the operator, the part operator interaction. And you can see that there is operator C on the bottom there that's consistently lower. Next slide, please. So what are the best ways to improve your MSA? First of all, you got to use common sense. There's an analyst with consistently skewed results. You want to add them to the study to sort of understand what's going on. You don't want to cherry pick the best samples of parts. You got to understand that people are going to be skeptical about the motives of MSA, especially if one's never been done before. You want to get your equipment lined up first, and then you want to work on your operators next. When we're doing an MSA, the focus is on the measurement system and not the parts. You spend more time preparing and planning the MSA. It's going to be more valuable than spending a lot of time conducting the MSA. You may need special care to preserve the sample's integrity during the study, and you may need backup samples and parts. Next slide, please. Like I said, the standard MSA is 10 samples, 3 operators, 3 replicas. If I increase the number of samples somewhere between 15 and 20, I get a significant improvement in my MSA. But once I get beyond 20, the improvement becomes much more marginal. If I'm trying to add more replicates or analysts to a study, to reduce the number of parts, it's not effective. And if I try to add more replicates or analysts with the same number of samples or parts, it doesn't improve the results. And you want to make sure that your parts are evenly spread across the range of the process variation. So it's much better to have 10 samples or parts that are evenly distributed throughout the range than your analysis of doing 20 that are clustered about the mean. Pay attention to what the number of distinct categories. 5 is the minimum, and think about what that means. That means you're going to measure on the low end, you're going to measure below average, you're going to measure somewhere near the middle, you're going to measure above average, and you're going to measure on the high end. And then you're going to manage the results to avoid blame. Next page. Here are some references. The first two are the ones that I would recommend the most. Even if you don't have Minitab, you can get their help screen on the internet. And it's about the only program I've ever used the help screen on. And it does a very good job of explaining all these different things in ways that are easy to understand. And the next one, Measurement Systems Analysis by AIG, is really sort of like a 50-page Bible of MSA. Next slide. If you need to know where to get some of these things, Minitab is typically what I've used in the past. I think it's very good for manufacturing. I know the folks in our technology group use JMP. Both of those two programs are rather pricey. Dennis Ducharme recommended Sigma XL, which is an XL add-in, which is a lot more price friendly. And then there's even various spreadsheets that you can get out on the web. And finally, I love Gilbert, and I thought this one was great. So the pointy-eared boss says, what does the data tell us to do? And Gilbert says, we only have bad data on this. Well, then the pointy-eared boss says, does the bad data suggest we should do what we wanted to do anyways? And Gilbert says, well, yes. And then the pointy-eared boss says, well, that's called good data. Kurt, it's up to you.
Okay. Let me change gears here. And again, thanks, Gary. That's like I said, brings back some memories of some of my MSAs and some of the things I've done and learned, and some of the watchouts. That was really good. Thanks. Okay, I'm going to change gears here just a little bit, and I'm going to pick up something that again was brought up by people in talking about a little bit about project management. And again, we call these sessions lessons learned from the trenches. So I want to kind of give you a high-level overview of project management and some of the things I've learned along the way. So first, to talk a little bit about me, I'm a quality professional with 40 years experience in manufacturing. I was trying to figure it out, and I said, well, I don't have the exact number, but I said if I took a rough guess, I'd somewhere between 60, 80 projects I've been involved with over my career. That's just assuming, two projects a year. Sometimes there's more, sometimes less. And I've had 5 years in the quality project as a quality project manager. And my primary focus at that time was on SAP QM implementations across multiple divisions within the company. I've had my share of project successes, but more importantly, I've had my share of failures. And that's really what I want to talk about today. So with that, I want to talk a little bit about just some of the elements of what are some of the key features or some of the things that you want to look for to try to minimize those failures. So I kind of started looking first at what type of failures, and what were some of the failures that I've had in projects that I've worked on. The biggest thing is when you're doing a project, you've got a team, and there are people who may not be directly under your control, asking them to come together and help with the project. So you may have an ineffective project team, and that could be that you've lost team members due to turnover, downsizing, or promotions, or any number of things. You may lose a team member along the way. You may have teams that just aren't engaged in the project itself. They're just not. They never really bought in. They're just there for the meeting, so you gotta worry about the team engagement. You can also have meetings that get hijacked by people giving you helpful suggestions or Monday morning quarterbacks saying, well, we should look at this. We should look at that. I think that there was one time I was looking at a project that was dealing with trying to streamline the cycle time, reduce cycle time. And the production supervisor, the production engineer that was involved, was using this as wanted to get a new forklift for the department. And so, if we had a new forklift, it would be faster or something like that. I don't know. And so they were, trying to help suggestions and try to steer and guide the direction. So you can get the meeting hijacked pretty easily by people who have their own agendas. A lot of times you have lack of committed support functions. This is a project that involves maintenance, IT support, and the production area and possibly quality assurance. And some of these support functions may not be high on their list. You can have shifts in corporate direction or leadership. I've had a project where I had the person that was leading the project or the sponsor of the project left, and the new person came in and just had a totally different view of what the project was. In general, it leads to things like scope creep. You miss deadlines, and then you can also fail to meet the project objectives. So these are the types of things that have hit me along the way. And so what I wanted to start with is what do you do to control that or to minimize that? So with that, I said the first thing is step one would be start with a good project charter, and that's a formal, typically short document that projects the project in its entirety. It's basically the elevator pitch to management to get their approval so that you can proceed with the project. And the elements I'm familiar with, and that there are templates. I want to show you one that I found that I thought was pretty nice. But typically the project has a title. Big thing that you need here is who is the project sponsor. In Six Sigma terminology, that would be your champion. And who is the person? This could be a VP. This could be someone up in the organization, and they're the ones that are really driving this project. You also want to list on that who the project manager is and the team. What is the project team and what functions do they serve? You also include on that charter the document approval date as well as revision dates. And I think it's important to have revision dates because that shows that this can be a living document. You don't want to change it at every meeting, but you do want to be able to, as conditions change, you may want to change the nature of the charter. So I like the idea of you have the approval, and that doesn't mean it's done. You go throw it in the file cabinet and pull it out at the end of the meeting of the project. It's really a living document. It has a project description. What is it you're trying to do? Big thing. One of the biggest things I think that I've learned is to really spell out what is the scope, what is in scope, and what is out of scope. That's how you get your project engineer or your process engineer who wants a new forklift. Keep him at bay, by spelling out what is the scope, and then also the business case. And again, for the project sponsor and for all the leadership, they want to know what's it mean in dollars and cents, and what is the business case for doing this project. More parts to this include you want to make sure that you've listed your constraints. What's the time? What's the budget? The scope, and if there's any quality constraints that you can't have an impact on quality or things like that. And that's very important to include as well. And again, so that the person with the forklift, if you're trying to debottleneck or and you don't have much of a budget, they could show that and say, hey, it's not in the budget. We're not budgeted for brand new equipment. It's more of a engineering studies and improving the process. List the project deliverables. What is it as a result of this project at the conclusion? What is it we're going to see? List the benefits, and I like the way it's laid out as if you have KPIs, what's your current baseline, and what is your target or your goal for those KPIs? Also list the steering committee or the stakeholders. And, this should include the members of the team, their leaders, their management. So that, again, if you've got someone from IT, you want the head of IT there, or maintenance, so that you can get their support, as well as you can let them know if a team member's not cutting it, it's, hey, I'm needing a little help here, needing a little drive. You're, holding up their progress because you're pushing them off onto other projects. I need the help of the stakeholders. And then above all, you want to make sure you include risks. One of the phrases I've heard or keep hearing in my head over the years is "Don't nobody bring me no bad news," and it was a song from The Wiz. And I think a lot of times when we deal with management leadership, you kind of go into a meeting with that in mind, but you really need to bring up and be realistic of what the potential risks are of doing this project. It could be that we are doing something that's bringing on new technology that hasn't been tested, that we don't have a lot of support, and experience with. So there's going to be a learning curve along the way. Those types of things need to be raised as a part of the project charter, so that if all of a sudden we do hit a bump in the road, we can say, did we foresee it? Did we list that in the risks? So I thought that was that's something over the years I've done a much better job of listing the project risks, and at least getting them out on the table early. This is the format. The one that I was used to using was about a 2 or 3 page, again, depending on how much you write up on the scope and the business case. It got a little unwieldy, and this one I thought was really nice in that it's basically a 1-pager that lists the information I just talked about, and it spells it out in a nice, easy to use format. And so this is, what I'd consider like a good starting point. You start with your project, you develop it. Again, you're securing the support of leadership. You got your project sponsor who's wanting you to do this, and then you're going to get together with your team when you start you form the team. You'll want to review this as one of the starting points. And again, the team may help assisting and refine things like the scope, the constraints, the deliverables, benefits, and so on. I think a lot of times you'll get some of the people who are specialized in their area that you might have estimated, hey, this is going to take about 4 weeks, and they might tell you, oh no, that's going to take about 6 to 8 weeks. So again, they can help you in terms of really laying out what the constraints are, and also, like I said, help you to refine the scope and deliverables. So you get your charter, you got it started, you got it approved by your sponsor or champion who really wants this project to get going. The next step is to assemble the team. And there was a Tuckman's model for teams, or team dynamics, and it talked about the stages of growth. And a lot of times your initial meetings may seem a little disjointed or a little tough they don't go as planned. And again, you have to understand that when a team forms, they go through stages. There's the forming, storming, norming, and performing. And if you hadn't heard this before, I'll just kind of quickly go through. But in the forming stage, that's early on. The individuals don't know what the team's purpose or how they fit in necessarily. They might be anxious or curious or even excited to get going. Like they said, they want to get that forklift. They want to, they come in with what their preconceived notion is. But they'll be looking to the team leader for direction. So it's important on the leader in that early stage is to understand that it could be a little chaotic initially. As you go and start to progress, the storming is where the members start to push against established boundaries. This causes a lot of conflict and friction. Who's doing what? They may challenge the leader's authority at times, or management style, or even the team's mission. There's also can be a point of frustration if the roles and responsibilities aren't clear. But you get through the storm, and they start to norm. They start to function together, and the team resolves differences. They appreciate each other's strengths. And then they have a shared commitment to the team goals. And so, then you're starting to get to well-oiled machine there. And the key is to try to get through those first two stages as quickly as possible. And then once you get to the performing stage, you're operating at full potential, and the team is considered fluid. By that means the members can take on various roles as needed. And so they'll pick up where there may be a gap, and they can kind of jump in. So, the whole idea for a good functioning team is to get to that performing stage, but understand that on day one of that first initial meeting, you might find you're informing and it might feel a little uncomfortable. So with that, you start your kickoff meeting. And a few things I've learned over the kickoff meeting, few important things is you first want to introduce the team. And this isn't just a meet and greet. I mean, you may know, and people may know each other, especially if it's a small organization. But you want to establish roles and responsibility. I've got Gary on the team because he knows MSA, and I've got this person because he's our IT support, and so on. So they understand what everyone is doing. You're going to review the charter again. Look back at the deliverables, the scope, deliverables, timeline. Get a reality check from them. Someone may come in and say, well, that's not going to be possible because, there's something else going on that you weren't aware of. And again, be prepared to adjust the charter if necessary. As you're assembling the team, just general terms about meeting mechanics. And these are things that I wish I could say I do every time. I know that I don't, and it's what causes a lot of headaches. But the very first thing is you want to send out an agenda with the meeting objective in advance so that they can read it. I think the leadership I used to work with referred to the term as pre-read it before the meeting. So that that they know as they're going into this meeting what to expect. Again, initially it'll still be in that forming stage. It's still a little chaotic, but at least you get that to them ahead of time. Agenda items should include time estimates. We're going to review the project charter, and I'm going to take the first 15 minutes of the meeting to do that, or maybe the first 10 minutes will be I want to introduce the team members. And on that agenda, you spell out how much time you're going to take on each. With that in mind, I said it's good to establish a timekeeper. It may not be you leading the meeting, or whoever's leading the meeting may ask someone to keep track of the time. I worked with one woman, and she was amazing at keeping us to the agenda. And I referred to her as our border collie because she kept us in line and she kept the meeting running. And if something started to go over, she would stop, say, hey, we're starting to go over. And at that point, we'd come to the question of, do we continue this? Do we make adjustments to the schedule? Or do we just agree to pick this up at the next meeting? So again, having a border collie on your team is a good tool, a good person to have. You might appoint a scribe if possible. Someone might be willing to take notes for you so that you can be up there presenting, talking. You can have someone help with the minutes. After the meeting, publish the minutes. Again, just as the agenda gets out ahead of time, get those minutes out timely as soon as possible after the meeting. Include in those minutes action plans. If there's any actions, responsibility, and timing, spell them out. Who's going to do what, when, and when it's expected to be done. You get those minutes out, and then before the next meeting, it's a good idea to those people who have action items, touch base with them ahead of time to say, you said that you were going to do a measurement system analysis, and I'm hoping you're going to have that so that we can review this at the next meeting. And that's helped set the tone and the standard so that they don't come into the next meeting saying, oh, yeah, I'll get that next week. And, again, I've had those things happen where action items just get, kicked down from one meeting to the next and eventually not done or done poorly. So it's kind of initially to keep tabs with the people who have actions and make sure they can come into the meeting prepared. And again, as you go through that development, once they get into the norming and performing, you don't need to do that as much because people understand and you've set the standard. And the biggest thing, and the thing that I have done the most, the thing I'm the most ashamed of, I think, is avoid postponing or canceling a team meeting, because that speaks volumes to the team members. There were times where, I found out that things aren't getting done, and rather than bring that up at the meeting, get a meeting and talk about it, I avoid it. I said, well, let's just give the guy some time, and we'll meet next week instead. And it just set the wrong tone. And eventually, some of the members lost interest, and it just, the meeting itself floundered, or the team floundered. So those are the things for the meeting. Then the other thing you want to have is leadership reviews. And these are periodic reviews. And again, here's the, don't nobody give me no bad news, but this is a time to meet with the sponsor champion, the stakeholders, have them regularly scheduled. If it's a 6-month project, you may want to meet monthly or every 4 to 6 weeks. Tell them where you are, what's going on, and also review the setbacks as well as the progress. Let them know if you're not getting the support you need from a function. The champions in there, if the stakeholders, the leadership for the different functions are there as well, that the sponsor can look at them saying, why aren't we getting our maintenance support? Use a consistent format that's easy to follow. You don't want to spend 30 minutes of an hour meeting trying to explain to them what they're looking at. One of the things that was used at the company I used to work at was an A3. An A3 is a size of paper, and it's just a real simple summary of this is the project, this is where we are, and it's well laid out. But I would say, check, what does your company do for project reviews? The place I'm now, everyone is so used to using a PowerPoint slide deck. And so, an A3, if I were to go into a project review with an A3, they'd be looking at it and saying, what is this? And it's like, no, that's wrong. You need to use our slide deck. But just to show you, this is what an A3 looks like. And it gives you the background, current situation, some of the analysis, and what we're trying to accomplish, what the recommendations are. You got a little Gantt chart, and then what's going on. And again, it fills in from left to right. And as you get near the end of the project, the lower sections fill in. Then finally, you get to your project closeout. And that's when you meet with a team, you review the project, were the objectives achieved? And again, sometimes it's not. You want to understand why, and that's why you do an after action review. And you want to get feedback from your team on what worked and what were the opportunities for improvement, and were there any lessons that we learned along the way. It's also good to celebrate project completion. I had one project I worked on, and the leader did a fantastic job of getting in there, everyone, and he got us all recognition awards and that nice little, just a little plaque. And it was well appreciated. And I was very willing to work on a project with him again after the way he treated everybody. It lets the team know that you appreciate the efforts, and ending the project on a positive note will secure support for the future projects. And like I said, it's easier to get your team to the performing stage if you've got a good history and you recognize the work that people have done as part of Project Closeout. And I, of course, had to do my cartoon. So it says, well, I've finished the project on time and on budget. So the boss says that means I've given you too much time and too much money. So just to wrap up, if you look at the failures I talked about and the countermeasures, we have an ineffective project team. You need to understand what the team dynamics are, and the fact that maybe you never got out of that forming and storming phase. Lack of engagement. The meeting mechanics I mentioned. Set expectations. Make sure if people have action items that they come to the meeting prepared, and set that expectation, and people tend to fall in if you set it and expect it. The Monday morning quarterbacks, again, have that project charter, have a well-defined scope. And if someone wants to start saying, well, we should do this or we should do that, you can say, well, that's really out of our scope. In terms of downsizing and turnover, loss of team members, it's good to have the project charter as well as meeting minutes. You can bring a new member up to speed. It's still some growth and some time, but at least you give them access to the past information. They can kind of see the path you've been on. Lack of committed support functions. I said the include the support function leadership in your stakeholder reviews. If you've got IT, if someone's from IT or maintenance or quality assurance on your team, you want to make sure their boss is involved or invited to those reviews so that they can see, one, that the person's doing a good job, or that we're getting behind and here's why. Shifts in corporate direction. I've had this happen. I said I had a VP that wanted to change, where everything was, and again had to introduce her to the charter and really show her, what it was that we were trying to do. And she looked at the assumptions, and one of the things, the scope, she wanted to expand it a little bit. It made it a little difficult, extended it out, but she was willing to do that. But it's something that, having the charter, you can at least say, this is what I had planned to do. If you're not comfortable with that or need to change it, you have to also understand that changing the scope will also change the timing. Scope creep, again, stick to the charter and the scope. Missed deadlines. At your leadership review, back to that, don't nobody bring me no bad news. Communicate early and often. If you've got a 6-month project and you find out that some of the equipment is going to be an 8-month lead time, tell them that as soon as you know. Don't just try to kick down the can down the road hoping something speeds up and by a miracle the equipment's going to get there early. Let them know early on that, hey, this 6-month project is going to have to be extended 2 or 3 months because of the lead time. Failure to meet project objectives, it happens. You sometimes don't have the equipment doesn't do what it was expected, or the software doesn't do as promised. And so again, hit it up at the leadership review, and in your after action review, talk about it, figure out what went wrong and what do we do different. Few references that resources I'll talk about was the Six Sigma Way team field book is something I use quite a bit, and it gives some pretty good description on how to set up and what's in a project charter, and I thought it was pretty good. And then another one that I'm reading now and then working with is the managing to learn using the A3 management process to solve problems, gain agreement, mentor, and lead. Long title, but that's one that really covers how to build an A3 and what its intent is. So with that, I just want to say that thank you, everybody. Are there any questions or comments? And I believe you can take your phones off mute. And also, I believe everyone has, looks like they have temporary access. Everyone has temporary access to the chat. Okay, before we leave, I just want to make sure you take the time to fill out the voice of the customer survey. I will just paste a web link into the chat. Let me do that right now. If you're looking on the Teams page, you should see if you click in the upper cartoon, the balloon, the dialogue balloon, you should be able to see the chat and the link to the survey. If you can't see that, I will send a URL with your participation letter. And then here is the QR code. And so if you want to just pull out your phone, take a picture of the QR code, that will also take you to our VOC survey. And with that, I want to thank everyone for your time and patience. Gary, did you have any closing comments or anything else? Anybody?
No. Thank you all for attending. We appreciate it.
Thank you. This was great.
And
thanks, guys.
I will be putting these presentations out on the My ASQ. So if you haven't gone there, please do. I'll put the PowerPoint presentations out there, and I'm still trying to figure out the right home for the video. And so, once we do that, I'll send a link there as well.
Can you put the QR code back?
Sure. Hang on.
Thank you so much.
That work for you?
Flawlessly.
Okay. All right. Well, again, I want to thank everybody for your time. And if there's no other questions or comments, we will see you in April. Watch for the announcements in the newsletter. We try to send the newsletter out a month early. And we're still trying to figure out when we can be face to face again. But again, I think we're not quite there yet.
Thank you, Kurt and Gary. Excellent job.
Thank you very much.
Thank you
Thank
very
you.
much.
Okay.
We'll see you. Okay, stop recording.